Okay, as I start talking about this, we need to recall our prefixes for the SI units. And these are the SI uh, prefixes here, starting with the largest here, which is a yata, sorry, which is 10 to the 24th. And then it goes downwards here and then downwards this way. So this is the biggest one here, and this is the smallest one over on this side that we have on this chart. There are others as well. The reason I'm bringing this up is because I told you originally that there were four that I wanted you guys to focus on. I wanted you to focus on a kilo, I wanted you to focus on centi and a milli, and also a nano. Okay, well, the nano is what we're going to use when if we talk about light. However, talking about fundamental forces, we actually have to focus on femtos. Okay, now if you take a look here, femto is the exact reciprocal or inverse of a peta. Okay, now remember how we counted these out. Mega was million, billion, trillion, and now a quadrillion. Okay, 15 zeros after the one. Okay, this is one divided by that. Okay, so that means that we have our decimal point, and then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is a femto. Okay, super duper duper small. So when we're going to talk about the strong nuclear force, we need to talk about a femto. Okay, it's a super duper small number. All right, so the chart that I showed you on the previous slide is this one right here. And as we look at it, what we're going to see is a relationship here. We have our distances, and it says relative distance here. Okay, so this is our distance line right there. And then we have our forces. Now this is, it says 103, but really what this is 10 to the 3. Okay, for some reason they weren't able to do or they forgot to do a, superscript on the 10 here. So it's 10 to the 3. Um, on other charts that you see, they could be 10 to the 4. Okay, so in other words, this is an exceedingly strong force when it gets down to this point. Here we say that the negative number here is attractive, and the positive number here is repulsive. Okay, so as we know, when we talk about like charges, when we bring like charges together, so um, if we have a say a positive and another positive, and as they come together here, what they're going to do is they're going to push away from each other. Okay, this is repulsion. Okay, so that's what they're going to try to do. But when we start getting into this really close range, this femtometer range, okay, what happens is as we get closer and closer, notice what these lines are doing. Okay, so this one happens to be neutron to neutron reaction. Now, neutrons don't have charge. So as they get closer, what they end up doing is they start to attract, okay? And they attract at a huge amount when it gets less than 1 femtometer, okay? This is about a half a femtometer at this point right here, okay? So as we get closer and closer, all of a sudden this becomes attractive instead. Here we have the proton-proton interaction. So that is this green line right here. And notice that this is coming from up here. It is a repulsive when we are, they repulse each other when we're up much further than this, not femtometers, but when we're in micrometers or one of the others. We're up here, we're repulsive. Okay, so this line is going to extend out. Now, this isn't going to be an accurate, uh, not an accurate uh, depiction of distances or anything like that. But what we're going to be at is we're going to be up here with our repulsion as they get closer. So they're going to go from infinity, which they're not going to be very repulsive, and then they're going to start going up as we get closer and closer to each other. But then when we reach a certain spot, and this is down in this femto range, then they're going to start to become attractive to each other. So they're going to start moving towards each other, and then they're going to break through a threshold, and that threshold is going to be an area where they become attractive to each other. Okay, so all of a sudden they become attractive to each other and they glue together. Okay. Now, if we start to bring them even closer, so then they're touching so close that they're closer than a femtometer. Okay. So now we're getting into 10 femtometers to 100 femtometers. Okay, we start getting closer and closer, which in essence they are touching each other and they're squishing into each other. Then they turn and they start to become repulsive again. Okay, so that is going to cause them to now push away. Okay, so then they're going to be ejected out. So this is going to be where we're going to be held together at this point in the nucleus of the atom. Okay, so this is how we look at this particular graph. This is the strong force. Okay, so the strong force is this range right here. All right.